We build metal colossi spewing torrents of fire to rip our dreams from Earth's gravity. Then we drift these multi-billion-dollar marvels into the freezing void of space to pierce the mysteries of the universe. It is the absolute pinnacle of human ingenuity, a technical dream born in 1946 when astronomer Lyman Spitzer envisioned an off-world observatory capable of escaping the turbulence of our atmosphere forever. Yet, once inside the absolute silence of orbit, the unthinkable happened. The most expensive, ambitious, and massive space telescope ever created was completely unable to see straight. The instrument, designed to revolutionize our understanding of the cosmos, was brought to its knees by a curvature flaw of just 2.2 micrometers, a tiny fraction of the thickness of a human hair. It is the spring of 1990. The Hubble Space Telescope has just been deployed into orbit by Space Shuttle mission STS-31, carrying colossal expectations. The global scientific community holds its breath, awaiting the most distant and breathtaking images ever captured by humankind. Instead, the first data beamed back to Earth triggers a massive shockwave. Stars don't appear as razor-sharp points of light, but as blurry, ghostly halos. The verdict is devastatingly clear. The cause of this optical disaster is a brutal physical phenomenon known as spherical aberration. The primary mirror, the very heart of the telescope, had been ground and polished with exquisite smoothness, but its overall shape was fundamentally too flat. In an instant, the reputation of NASA and the entire aerospace industry is hanging by a thread, threatened by a defective piece of glass floating 300 miles above our heads. The media seizes the story, branding this technological marvel a techno-turkey and a historic fiasco. How can a space agency fix a microscopic flaw on a massive mirror trapped in the vacuum of space with zero possibility of bringing it back to Earth? The official investigation reveals a chain of events both fascinating and tragic. The failure didn't stem from the brutal violence of launch or the hostility of deep space. It happened inside a clean room on Earth. The critical mistake occurred during the calibration of the ground support equipment. A high-precision device called the reflective Null Corrector, meant to guide the precise curvature of Hubble's primary mirror during polishing, had been assembled incorrectly. Missing post-assembly checks and a misplaced measuring rod misled the entire optical system, creating a textbook case of spherical aberration born from a simple lack of independent verification. NASA was left with a tragically nearsighted telescope, but abandoning the mission was out of the question. From the engineering base, a wild, audacious idea emerged. If bringing the heavy mirror back down to Earth was impossible, they would have to send astronauts into orbit to give the telescope a pair of corrective glasses. This unprecedented rescue mission centered around one of the most complex space operations in history, STS-61, scheduled for December 1993, Hubble's first ever servicing mission. The technical solution carried a now legendary codename, COSTAR, Corrective Optics Space Telescope Axial Replacement. It was a massive module, roughly the size of a phone booth, containing an intricate array of miniature mirrors mounted on ultra-precise motorized arms. These tiny mirrors were meticulously designed to deploy inside the telescope, intercept the distorted light from the primary mirror, apply the exact opposite optical correction, and bounce the corrected light into the scientific instruments. It was a stroke of genius, yet an agonizing question haunted the engineers night and day. How could they be 100% sure the new optical prescription was flawless? If COSTAR, a $50 million device, failed, the mission was over. Hubble's fate would be sealed forever. Success demanded an uncompromising methodology. Experts calculated the precise optical error in orbit by analyzing actual blurry images sent back by Hubble, combining it with a rigorous independent teardown of the faulty ground equipment. Math proved both methods aligned perfectly. To banish the ghost of a second disaster, engineers built an insanely complex mechanical and optical simulator, HOMS, Hubble Optomechanical Simulator. Its sole purpose was to recreate Hubble's exact flaws on Earth. CoStar was locked inside and relentlessly tested under simulated zero-gravity conditions to guarantee it would fix the anomaly flawlessly. December 1993. The Space Shuttle rendezvous with Hubble. Over a series of grueling, high-stakes spacewalks, astronauts delicately remove an old photometer and install the CoStar module. They also swap out the primary camera for the new Wide-Field Planetary Camera 2, which carried its own built-in optical corrections. Once again, the world holds its breath. When the first corrected images finally flash across screens on Earth, the results are staggering, surpassing the wildest dreams of the scientific community. Pristine clarity is restored. The telescope achieves an optical resolution unprecedented in human history. This spectacular resurrection didn't just save a flagship mission, it ushered in a dizzying era of high-contrast deep space imaging and catapulted the science of exoplanets into a whole new dimension. With its vision restored, Hubble probed planetary nurseries with razor-sharp acuity, capturing massive debris disks surrounding young stars like Beta Pictoris. These observations revealed an unexpected warp in the star's dust disk, strongly hinting at the gravitational tug of an unseen giant planet, validating core theories about how alien worlds are born. Without CoStar, these vast dust rings, buried in the blinding glare of stars thousands of times brighter, would have remained hidden forever. Even more fundamentally, the legacy of this crisis permanently reshaped how humanity builds space observatories. The painful lessons of a 2.2 micrometer mistake forged strict new protocols for the future. For Hubble's successor, the massive James Webb Space Telescope, testing was radically different. Engineers applied an almost obsessive level of verification. Deep inside the giant cryogenic vacuum chamber at Johnson Space Center, Webb's entire optical suite underwent brutal environmental testing, simulating the lethal temperatures of deep space to ensure its 6.5-meter beryllium mirror would deploy flawlessly. Hubble's humiliating initial failure directly paved the way for Webb's absolute perfection. The extraordinary story of the Hubble Space Telescope remains one of the greatest epics of modern space exploration. From a tragically flawed mirror ridiculed worldwide to a resounding triumph of human resilience, it proves that our true ingenuity shines brightest in the face of disaster. In the end, those blurry stars became wide-open windows to the dawn of time.